Hello everyone. In this video, we'll be going over an example on deterministic finite automata. Okay, so we will be designing a DFA with alphabet 0 and 1 that will accept strings that start with 1 and end with 0. So let's think of the two conditions that need to be satisfied by a string to be accepted by our automaton. Those are the string must start with a 1 and the string must end with a 0. Now let's go ahead and construct let's call it a semi-DFA that simply will accept the most basic string that would be accepted by this machine, which is 1, 0. 1, 0 starts with a 1 and ends with a 0. So we're obviously going to start with an initial state. We're going to name that Q0. And then from Q0, if you read a 1, you will go to a new state, Q1. And then from Q1, if you read a 0, you will go to a new state. We're going to call it Q3, and it's going to be an accept state. This automaton here accepts the string 1, 0. Now, okay, we've seen how it should look for the most simple string that would be accepted. Now let's look at the most simple string that would be rejected, which, I mean, we have the empty string, but that's already demonstrated because if you just have an empty string, then you're in the initial state, which is Q0, and then you'll just be rejected there. The next simple string that would be rejected would probably be 0. So from Q0, if you read a 0, you will be going to another state, which we're going to name Q2. And if you're in Q2, this means that the string didn't start with a 1, therefore the string will always be rejected, since both conditions have to be true for the string to be accepted. So once you're in Q2, you will stay in Q2 and you will be rejected. And now we can simply just fill in for the rest of the automaton. We have shown the full transition for states Q0 and for Q2. However, we haven't completed the transitions for Q1 and Q3. So for Q1, we've shown what happens when it reads a 0, which is it goes to Q3, but we haven't shown what it does if it reads a 1. Okay, now let's think. I mean, Q1 is almost like the representation of when condition 1 is true, meaning the string started with a 1, but condition 2 is not true yet. So if you're in Q1 and you read another 1, well, condition 1 still holds, but condition 2 still isn't true because you haven't read a 0 yet. So if you get a 1 in Q1, you should stay in Q1. Q3, on the other hand, is the representation of condition 1 being true and condition 2 being true. So if condition 2 is at any point violated, then you must go back to Q1. Now, if we read a 0 while we're in Q3, well, that doesn't violate either conditions. The string still starts with a 1, and the string still ends with a 0. So if you get a 0, you will stay in Q3. However, if you get a 1, well, that violates our second condition, because now all of a sudden the string doesn't end with a doesn't end with a 0, ends with a 1. So in that case, you must go back to Q1. It's very helpful to try to view the different states as representations of conditions. So in our automaton, for example, Q0 is obviously just the initial state, but then Q1, just as I mentioned earlier, is the representation of condition 1 being true and condition 2 being false. Q3 is the representation of condition 1 and condition 2 being true, and Q2 is the representation of condition 1 and condition 2 being false. Realistically, it's just condition 1 for Q2, but since both conditions have to be true, if condition 1 is violated, then the string will automatically be rejected. And this is our full automaton for this example. We can go through some example strings to verify that our automaton works. So first we can just look at the strings and see whether or not they should be accepted. So our first string is 1010. Now this string starts with a 1 and it ends with a 0. Therefore, it should be accepted. So we can go through the automaton to verify it. We start at Q0, then you read a 1, you go to Q1. Then from Q1, you read a 0, you go to Q3. Then you read a 1, you go back to Q1. Then you read a 0, and you go to Q3. So you end up in Q3, which is an accept state, therefore the string is accepted. Then we have 1, 0, 0. Also should be accepted since it starts with a 1 and ends with a 0. And if we go through the transitions, it goes from Q0 to Q1, from Q1 to Q3, and then from Q3 on 0 it loops, and then it's accepted. Then let's look at one more. 1, 0, 1, 0 is a string that should be rejected because it starts with a 0. And we can see it starts at the initial state. You read a 0, you go to Q2. On Q2, you loop for 1, and then you loop for 0, and then you end up in Q2 where the string is rejected. So we verified the automaton holds for different inputs. You can try this out for yourself. You can even have larger strings. If the string starts with a 1 and ends with a 0, you will see that it will always finish in Q3. Otherwise, it will finish outside of Q3.